Hello students, welcome back to our paper CHO 5403. We are discussing chironophorus and some important drug synthesis, or I will say the natural product synthesis using cheapest starting material. As you know that we have already discussed so many compounds, our next target molecule is pentenomycin. As it suggests, the name is pentenomycin. It is an antibiotic used in the medicinal field. Okay, so pentenomycin is antibiotic which is synthesized from the simplest molecule, that is a D-glucose, which is naturally available in tremendous amount. So this is structure of pentenomycin. Pentenomycin contains a five-member ring with alpha beta unsaturated ketone and three alcoholic OH group. Among these two are secondary OH in the form of diol and third is primary OH. So this is structure of pentenomycin 1. So friends, let's start with the glucose. So you can see this first molecule, this is nothing but this is a protected form of our glucose. So this is structure of glucose. When it treated with the acetone in acidic condition, we get this 1256 diisopropyridine d glucanofuranones. So this is our first structure which is obtained from D glucose. So we get this acetyl protected form of our D-glucose. Now the reaction start. On each arrow we have 3 to 4 reactions. So for your better understanding, I have separate out each and every reaction. So first reaction is rhenium oxide and sodium periodate oxidation. As you can see here, there is no other molecule, no other functional group than OH is available for oxidation. This OH is oxidized to ketone in presence of first reagent. Okay, this reagent used for the oxidation of our OH group. Okay, this OH group is oxidized to keto group. So I have written down over here. First step is protection, and then RuO4 oxidation of this OH group to keto group. Now the next step is nitromethane reaction in presence of a base. So what will this base will do? It will abstract proton from this CH3, and this carbanion will attack over this carbonyl carbon and we get OH over here. So our molecule will be CH2NO2 and OH group over here. So it will attack from the top phase and our OH will be at the bottom phase. This is how we are getting this CH2NO2 and OH. Now second step completed. Now third is alkaline camenophore and then NABH4 reaction. So alkaline camenophore will hydrolyze this CH2NO2 into aldehyde and then it will reduce to alcohol. I will show you in the next slide. You can see here we have CH2NO2 molecule, and that CH2NO2 is hydrolyzed in presence of alkaline camenophore into CH2OH and then CHO and then NaBH4 will convert it into CH2OH. This is how our next reaction proceeds. So we get this kind of molecule which have CH2OH from CH2NO2 and this OH over here. So we get this molecule over here. So next reaction is use of TSCl and NaOBN. So this is a NaOBN and TSCl. So what this TSCl will do? This TSCl will now react with this primary alcoholic OH group. So I will again repeat the reactivity. The primary alcohol is protected very fast, then secondary and then tertiary. But when the time comes for the deprotection, tertiary deprotects first, then secondary, and lastly we get the deprotection of primary alcohol. So for the protection, this TSCl will only react with the primary alcohol and we get OTS over here, and that OTS is displaced by OBN and finally we get OBN over here. So it is an indirect protection of OH. So we get OBN over here by this nucleophilic substitution. So once we get OBN over here, the next reagent is 60% aqueous acetic acid. So 60% aqueous acetic acid will deprotect this acetyl protection. So it will be deprotected by this acetic acid. We get again this diol over here. Okay, so this is how we come up to over here. We get OBN and then diol by the deprotection with the help of acetic acid. Okay, now let's go for the next reaction. Next reaction is very simple. It's a NaIO for oxidation and then NaBH for reduction. So friends, can you guess which functional group will be affected with this NaIO for oxidation and then NaBH for reduction? You can see over here. This diol is oxidized. Okay, the above diol is oxidized by this NaIO4. So we get one molecule of this formaldehyde and again another aldehyde over here. Now we have CHO over here. This CHO then reduced with the help of NaBH4. So we get CH2OH over here like this. I have shown over here. We get oxidation CH then reduction of aldehyde. We get CH2OH over here. Now we get CH2OH over here, OBN and OH is intact. Now the next reaction is with the TSCl pyridine. This primary OH now attack over TSCl and we get OTS protected form of our primary alcohol. Now we have OBN over here, OH over here. Now the next reaction is methanol in H plus. So this is very interesting reaction. What will this methanol will do? It will attack over here and then deprotection of this acetal we get OMe and OH over here. So once we get OMe and OH over here, the next reaction is with this 2,2-dimethoxypropane. This is Me2COMe2 is nothing but is Me2COMe2. That means 2,2-dimethoxypropane, and you know that this reagent is used for the protection of this diol. So this diol is protected with this 2,2-dimethoxypropane and we get this kind of molecule. Okay, this is a protected form of this diol, or here we have OMe. So this is how we come up to this molecule. Come up to this molecule. Now the next reaction is treatment with potassium tertiary butoxide in DMSO. This is a simple, I will say, elimination reaction. What this uh, potassium tertiary butoxide will do? It will abstract proton from this carbon. Okay, we get negative charge over here, and then there is a elimination reaction. Okay, this is the elimination reaction, and thus as we are using strong base, only elimination is possible. So we get double bond over here. OBN is already there. OMe we get from the last reaction by the treatment of methanol and HCl, and then this is a diol protected form of acetal protected form of diol. So we have this molecule, and the next reactions are on this molecule. I hope it is clear up to here. Now let's go for the next slide. So next slide, we already have that molecule with the double bond over here. So if you look at this molecule, this is a double bond over here, and this is the again acetal protected form, OR and OMe. This is acetal protected. So next reaction is just a deprotection of this acetal. So once we do the acetal deprotection, we get this COMe and CHO over here. So friends, don't confuse with this uh, molecule. This is just a CO over here, and this CH2 is now converting into Me. So COMe and this will become CHO. So our next molecule is COMe and CHO over here by just acetal deprotection in presence of 80% aqueous acetic acid. So this is how we get this molecule. Now next reaction is very simple, but in practical they tried so many different reagent to get the stereochemistry correct. So this is a aldol condensation reaction. So this alpha hydrogen is abstracted and we get aldol condensation between this keto and aldehyde, and by dehydration we get this alpha beta unsaturated ketone over here. Okay, we get alpha beta unsaturated ketone over here by intramolecular aldol condensation reaction. Okay, now once we get this aldol condensation, next reaction is a treatment of acetic anhydride. So what this acetic anhydride actually do, it will deprotect, or I will say simple displacement of OBN with OAC. So we get OAC over here. This is a simple reaction is done with the help of acetic anhydride. So our OBN is now replaced with this OAC. So this is a reaction, and then now we have acetyl protected and this acetyl protected form. Now treatment with this lipase enzyme and simple deacylation with the trifluoroacetic acid will reprotect these two protected groups, and we get this OH diol over here and then primary alcohol over here. So this is how we get the pentenomycin 1 from our glucose. So reactions are very simple. If you guys have any doubt regarding this synthesis, feel free to ask me. Thank you.